Really three steps that you have to go through to prove by math induction. The first one is to show that the sequence, the series that you have is true for the first value, which is n equals 1. So if in this equation, if I plug in n is 1, I'll have 1 on the left side, 1 times 1 plus 1 over 2 on the right side. And if I simplify, I'd have 2 over 2 on the right side, which is 1. So it's true for the first term. And then the next thing you need to do is just assume that it's going to work for n equals k, which means you're really just rewriting the sequence, but instead of having an n in there, we're going to have a k. Right, and then what we're going to do to prove this is we're going to show it works for the next term. If it works for the next term, then it would have worked for every term prior to that. So to do that, we're going to have to add the next term on. So on the left-hand side here, if I add the next term that comes after k would be k plus 1. And really that k plus 1 is key to this because that's the value that we're going to add onto the right-hand side as well. So that's going to look like this. This term stays the same. We're going to add on to that same thing that I added to the left-hand side. To keep the equation balanced, I need to add the same thing to the right-hand side. And then you're going to work on this right-hand side to simplify it so that this looks like the next term. So instead of k, it would be k plus 1. Instead of this being k plus 1, it would be k plus 1 plus 1, which is plus 2, and the denominator would stay the same. This is what we're trying to simplify to. All right, so let's work on this right-hand side then and see if we can make it look like that. So if you look at these two terms, maybe you would find a common denominator. So I'd have k squared plus k in the top over 2, and maybe make this 2 over 2 times that k plus 1. Now I can put this all together, which is k squared plus k plus 2k plus 2. And then that numerator, if I can combine those like terms together, I would get a 3k. And then that factors into k plus 1 times k plus 2 all over 2, which is that next term. Instead of being k, now the next term is k plus 1. Instead of k plus 1, it's k plus 1 plus 1, which is k plus 2, and it's still over 2. So you've proved that one by math induction. If we look at another problem similar to that, but maybe a little bit trickier there with some exponents. Same idea, so we got to show that it works for the first term. So if I plug in n is 1 to both sides, then simplify, I'll have 2 to the 0, which equals 2 minus 1, anything to the 0 power is 1, equals 1. So it's true, it works for the first term. And then we go through that next step where we just rewrite the same sequence of values there, but instead of using the n, we're going to use the k value. Okay, and then if it works for the next term, then it's got to work for every term prior to that. So we're going to add the next term on. The previous term. The next term would be 2 to the, instead of k, it would be k plus 1 minus the 1 that's there. Right-hand side stays the same. This value that I added to the left-hand side, I'm going to add that same thing to the right-hand side. All right, and 2k plus 1 minus 1 is really just 2 to the k. On the right-hand side, if we simplify, I'm going to somehow put this together so it looks like what the next term would be. So for this term right here, where we plugged in n was equal to k, the next term would be 2 to the, instead of k, it would be k plus 1 minus a 1. So that's what we want to end up with. Well, if you put these 2 to the k's together, I have 2 of those 2 to the k's. And 2 to the 2 times 2 to the k would be 2 to the first times 2 to the k. And if you multiply the same base, you can add these two exponents together and just write it as a single base. And then if you look at that, that would be what that next term would be, 2 to the k plus 1 minus 1. So we've proved it by math induction. If it works for the next term, then it worked for every term prior to that. Now the third example is the one that you had for one of your review problems. So there it is. So same idea. So if we assume that this works for the, or try to show that it works for the first term, so if I plug in n is 1, I'm going to have 3 minus 2, which is 1. I would have 3 minus 1 in the top, which is 2 over 2, which equals 1. So the left side equaled the right side, so at least works for one term. Now let's go ahead and plug in n equals k. So the series of numbers is the same. Take out n and replace it with k. And then we're going to add the next term on, and if we can show it works for the next term, then it had to work for every term prior to that. So if I add the next term on this side, it would be 3 instead of k. It's k plus 1. You still have the minus 2 and the times 3 out in front. On the right-hand side, this is exactly the same, but I'm going to add this term that I add to the left side. I'm going to add that same thing to the right side. And then I'm going to simplify on this right-hand side. And again, I want this to look like the next term. So instead of k, that should be k plus 1. Instead of 3k, it should be 3 times k plus 1 minus a 1. And then that whole thing is divided by 2. That's what I'm shooting for. So over here on the right-hand side, I'm going to distribute this and see what I can do. So I'll have 3k squared minus k, and that's over 2. This second term here, I have 3k plus 3 and a minus 2. So this term, if I combine the 3 and the 2 together, I have a 1. So I have 3k plus a 1. Now I'm going to find a common denominator, which means if I put this over 2, I'd have to multiply by 2. So now I can write this as one big fraction over 2, and that's good. I want that final answer to be all over 2. And then I have 3k squared plus 5k plus 2, and that's all over 2. And really what I just need to do is then factor this thing. It's almost where I need it to be. So this will factor into 3k and k. It'll be a plus 1 and a plus 2. Now I'm almost there. I need the k plus 1. I need to fix this to make it look like what I have up here. So I'm going to put the k plus 1 first. And that 3k, if I factor out, if I rewrite that 2 as a plus 3 and a minus 1, I can factor that 3 out of both of those terms. So I can make that 3 times k plus 1 with that minus 1 second, and then the divide by 2. And that's exactly what I wanted that thing to equal.